Hello, my name is Ana Sofia and I'm gonna explain this part of the evidence and all of the problems um, through this video. So in the first problem, it asks us the volume of the water. And so what I did was take out all of the data that the problem already gives us and then see which formulas would help me and which other formulas I would need to get to the formula that I actually needed. So what I did was I took the formula of pressure equals mass over volume, and knowing the pressure, no, it was the density. And knowing the density, which the density of the gold, which was 19,300, equals mass over 0.00000001, which is the volume. So then I get the mass, and it's all of those 0.000, I don't know how many zeros, 1 meters cubic times 19,300 gives me the mass, which is equal to 0.00193 kilograms. And then, knowing the density of the water, which is 1,000, I know the density and the mass. So I use again the density formula, which is density equals mass over volume, and substitute the letters for the numbers, and then I have volume equals to 0.00193 over 1000 and get the volume of the water, which is 0.000000193, and the specific weight, which is the formula specific weight equals to density times gravity, and I use the density of the gold, which is 19,300 times 9.81, and get the density, the specific weight, which equals to 0.01893. In the second problem, it asks us the air pressure and the total force. So what I do is take the specific weight formula, and knowing the density and the gravity being 9.81, I get the specific weight, which equals to 10,104.3. And then using the pressure formula, I get pressure equals to density times height, and I multiply specific weight. I multiply the specific weight, which is 10,104.3 times 200, and get the pressure, which equals to 20,208. No, sorry. Which equals to 2,020,860, I think, or something like that, or maybe 2,208.60 pascals. I don't remember the exact point and decimal, but somewhere over the line. And to know the total force, I use the pressure formula again, which is pressure equals to force times area. So what I did was get the area, and then I multiplied the pressure times, I multiplied the pressure times 1.5, which is the area, and got the force, which is 3,031,290. Then in the third problem, it asks us the first force to lift the truck of 1300 kilograms. So what I did is, knowing that pressure equals to first force over first area equals to second force over second area, I got the areas, the two areas, and then I got the second force, which is force equals to mass times gravity, and so it was 1300 times 9.81 equals to 12,753 newtons. So I have the second force, and then I do like kind of a rule of three, regla de tres, and knowing that first one is my x over the first area, which is 0.0028, equals to the second force, which is 12,753, over the second area, which is 0.0176, and then I get multiplying the first area times the second force over the second area, you get that the first force is 2028.86 newtons. In the fourth problem, what it asks us is the air pressure, and what I did, they give us the radius, the two radius, but they give you the radius in millimeters, so you convert them to meters, and then you get the areas, again the first and the second, and using the same law or theorem or whatever, you get to the pressure. But for now, I first got the force, the second force, which with the force formula, which is force equals to mass times gravity, and so I got that 2,300 times 9.81 equals to 2,256.3 newtons. So that is my second force, and using that law, I did again the regla de tres and got the first force, which was equal to 493.56 newtons, and then with the pressure formula, the pressure equals to force over area. I got the pressure equals to the first force, which is 493.56 times 0.0028, which is the area, and got the force equals to 176,273.43 pascals. Now, in the fifth problem, they ask us the mass or the weight, the load that the globe withstand at that altitude. So you know the air density, we know the volume and the helium density. You get the buoyant force, which equals buoyant force equals to density times volume times gravity, and then you substitute the letters with the numbers, and you get the buoyant force equals to 0.9 times 20 times 9.81, and the buoyant force equals to 176.58 newtons. So that's the buoyant force. And in the sixth problem, they ask you the extra mass. So again, you get the radius, you get the mass of the globe, of the balloon, the density of the helium, the air density, and what you do is, with the formula of density equals to mass times volume, you substitute the density with the helium density equals to 50, which is the mass of the balloon, over volume, and then you get the volume equals to 50 over 0.178 equals to 280.89 meters cubic, which is the volume. And then with the formula of buoyant force equals to density times volume times gravity, you use the air density, which is 0.9, times the volume, which is 280.89, times the gravity, which is 9.81, and the result should be, or at least in my head, should be 2,479.97 newtons. Then that is our buoyant force. So now we get the weight of the balloon, with again weight equals to mass times gravity, and you get that 50 times 9.81 equals to 490.5, which is the weight of the balloon. And then using the same formula, you get the weight of the buoyant force, which is weight equals, no, in weight you substitute for 1009. Oh no, sorry. You restas to the buoyant force the weight of the balloon, and then you get the extra mass that can load. So with the weight formula, which is mass times gravity, you substitute the weight for 1989 equals to mass times gravity 9.81, and then mass equals to 9081. ¿Qué? Espera, mamá. Mamá, ya, espera, estoy haciendo un trabajo.